Now, thanks a lot, Ulrich, for this beautiful and very nice introduction. I'm seeing some familiar faces here, and I'm happy to be speaking in Niedersachsen, in Hannover, today, because normally I'm, wie sagt man, pendeling between Cologne and Halle, because I have one company in Cologne and one company in Halle, Saale. This is now first the advertising block. My company Corvey in Hanover indeed was the original bioregion GmbH. Yeah, and I created this logo, it's not here, of Bioregio Niedersachsen, and I was the speaker of this in the competition, Braunschweig, Göttingen, Hannover Bioregion at that time, in 1997. This was one of the very leading and probably one of the best initiatives of the BMBF regarding biotechnology in the recent 20 years, the Bioregio-Wettbewerb of Jürgen Rüttgers. Well, I founded the company in 2002 because at that time Niedersachsen wanted to have a management company for the cluster to really turn ideas into business. In 2006 we renamed the company from Bioregion to Corvey, because at that time we had started to have private business, so a consulting business, and today the company is active in consulting, in project development, and oh, this one is in German, partly. Funny. The company also holds shares in some of the projects which I have developed and which have become companies by themselves, like Bluecon Biotech in Cologne. Plastics from nature for nature is our slogan. There we are making bioplastics from residues from forestry and agriculture. I will come to that point later. I founded another company, this one in Halle, carbon footprint neutral chemicals for the plastic industry, Corvey Bioproducts. I have this little company in Hong Kong to take care of some Asian business. And this one, verkauft, sold in English, is VPM, which was mentioned by Ulrich, which was founded, it was not sold in 2002, but it was founded in 2002. I will come to VPM later. And then also I have a marketing and sales company for Corvey, for specialty chemicals. This is better to operate for me. I'm not so skilled with these little machines. Now, Corvey is consulting on strategy, on processes, business processes, on marketing and sales, on market access, yeah? Where you either for Asian companies to Europe or for European companies to India or China or even US. But currently I'm more working between Asia and Europe. And we are managing R&D projects, we are managing production projects, we are managing projects by themselves. So this is my introduction, this is what my company is doing. Now I'm coming to the topic. The title is From Bench to Market. But as I'm speaking here, let's see, surrounded by so many academic people, for many of you, or at least for the professors here, there's the question, am I working from bench to paper, to scientific evidence, to scientific brilliance, or am I working from science or from bench to market? And here, market, in the end, in the extreme end, market is stock market. And really the company has created a lot of value, lot of asset value, not only sales in terms of products, but also sales in terms of shares. Yeah, so this is a very extreme, very wide spectrum, and my votum already now is first go from bench to patent, and then you can write your paper, you can be a brilliant scientist, and then you still can decide whether you go to the market or not. And I think MAH is collaborating very well with Ascenion, a patent, intellectual property license office supporting MAH, and I I know Christian Stein very well because he was co-owner with me of VPM, and we sold the company together. So this is a good path to go. Yeah? And think of the patent before you publish your paper, before you talk about your brilliant science. Like big and well-known German companies, I could mention many hundreds, thousands of companies, but I'm mentioning few German examples because I'm speaking here in Germany. Keyagin, founded by the way by people having studied in Göttingen under Professor Eigen. Morphosis in Munich, Evotec, another spin-out of Eigen. Biontech, Curac, everybody knows these companies today because of COVID, and many others. And of course, one company to be mentioned here is Thomas Doom's Cardio. And I cross all my fingers I have that I see you here in the not so far future. So I want to talk about two case studies today, or cases, not really study, because I think it's for you more interesting to hear from the horse's mouth what he has done himself instead of analyzing diligently what Keyagin did and what Evotec did. Yeah, I could do this as well, but I think it's more interesting to get a practical insight what I was doing myself. So the two studies or the two cases are Vaccine Projektmanagement GmbH VPM, focusing on vaccine development, immunology, and since 2017, actually much earlier, Bluecon Biotech working on a process to make lactic acid from straw, and from this PLA, polylactic acid, should be made. And this is the bioeconomy project which Ulrich was referring to. And by the way, it was not really by very good thought or planning. It was very opportunistic. It happened that after I had left and given VPM to the next generation of management, I just happened to come to the company where the bioeconomy was done. It just happened. Opportunistic, pragmatic, whatever you want to say. Now, the case VPM. The preparing stage. The preparing stage of VPM was a very German funding-oriented program. And this has to be in German because it's the citation, a quote from the BMBF, wie sagt man, Ausschreibung, program structure. And here it says that die Impfstoffinitiative soll eine schlagkräftige Struktur schaffen, einen international sichtbaren Beitrag zur produktorientierten Impfstoffentwicklung zu leisten. Product-oriented vaccine development. And this is something interesting because a product is something to be defined. A product for a scientist is a molecule swimming in the soup, which you can detect with HPLC or GC or any chromatography or any photometry. A product for an industrial guy like me is something you can fill in a bag, and you have to analyze and make a certificate of analysis, and you have a safety data sheet, you have whatever sheet you need, a product information sheet, and this is what you sell to your customer. That's a product for the industry guy, and a product for the scientists. Sometimes when I talk to my scientists in my company, they are happy to see lactic acid in the soup. So this is not the product. We need to purify it. We need to calculate all the losses. Yeah? So, produktorientierte Impfstoffentwicklung. And when the BMBF was writing this, they probably didn't think as far as the industry guy when they talk about product, because also in the BMBF too many scientists are sitting. Not enough industry people, I think not even one. And so then they said the consortium should be an open structure with a management unit and different stakeholders. And the financing from public money, and after 6 years, after 5 years, the structure should be self-funding. The idea was to license know-how from the academia and continue to develop to a stage like proof of concept and sell the proof of concept stage to the industry. And from the returns of this these sold products, sold projects, the self-funding should have happened. So this was the start. This was the where we should go. Well, the second part of this start was something very, very useful, very, very intelligent by the BMBF. They said, if you want to license technology or patents, or, well, I'm jumping ahead. If you want to license academic inventions, yeah, then let's make an inventory. So this was called at the time Impfstofflandkarte. It was in paper, 3 files of about 200, 250 projects which we collected all over Germany, from university, from Fraunhofer, from Max Planck, and so on, research projects. And then we were, of course, we did this to select the best to be developed further. And the criteria there were the number one, the first priority was the patent. Because if the inventor doesn't have a patent, or the group doesn't have a patent, I cannot license anything. I don't have anything to touch. So there needs to be a patent, a good patent, by the way. And then, of course, that was the second criterion. But the first, we threw out already maybe 150 projects because there were no patents. Beautiful papers, beautiful publications. There were no patents. And then these people were angry. The big professors said, you have to take our project. I said, okay, we cannot. There's no patent there. And because I need to touch something. When I want to have money from an investor, the investor asks me, and everybody who has founded a company here knows that patents, IP situation is the first question. Yeah? Okay, then of course, what we find as a good patent, as a patent should be a very good patent, should be highly innovative. Yeah? And then the last, and this is only a selection of the 3 most important of maybe 10 criteria, but a very important selection criterion for a license is a personal fit with the inventor. Yeah, that you as a company, as a project development company, have a good understanding with people like Uli or Thomas, yeah? That we can also fight together, yeah? That you can reach common ground, because you will not always have the sun shining, but there will also be rain and hail. Yeah? And then we have to develop business projects, business models together. So that's why personal fit is extremely important. Now, in practice, what happened? A company was founded. Because a management unit, what is a management unit? A management unit, which the BMBF had in its brilliant mind, was something which should not become a company. Just a management unit. And then I convinced them, I said, we cannot just have a unit which has no legal basis, because without a legal basis, we cannot license. So we need a company. The company was founded in 2002, fully operational 2003. Very lean team, 5 people only. 1 CEO, 1 CFO and admin, 1 chief medical officer, Bernd Eisele, and project manager Leander Grode, today the CEO of VPM, and office assistant today, procurist Inge Jacobi. Yeah? So some of you, all of you may know these people, brilliant people. We had a very strong board called Kuratorium, and today's president of MAH was also a member of this Kuratorium. Very, very helpful. Yeah? 5 minutes of Professor Manz were very, very important for months of our work. he was so quick and so clear in his advices. We decided not to invest into any buildings or labs or apparatus, just into partnerships, because we wanted to be quick, and we had to be quick. 5 years is a very short time when you have to become profitable. In the end, we didn't become profitable, but anyway, we had to start. The idea was to keep the management know-how in-house, so have very strong people, like the project manager, medical guy, to guide the collaborations. We have always to be in the driver's seat, but to find the best possible collaborators for the production, for the clinical trial planning, for the clinical trial execution, and so on and so on. This made us very, very fast. We selected 5 projects initially. One of them was the TB, one of them was the CMV, and these 2 are still continued today. Well, the company was sold in 2018 to Serum Institute of India, part of it. 10% is still owned by the Freundeskreis Förderverein des HZI. So, in the end, a success story, because we survived and we could sell it. But it went through many difficult stages. Before I come to the learnings of this, I show you the basic principle, which is, well, all of you in train know this graph. Yeah? Probably all of you have seen the presentation of VPM, and I stole this, and I didn't steal it because I made it. So, so the basic principle of the work is, well, from left to right, but is this one. That when you're today in, what is it now, 2020 here, you have a candidate and you know that maybe this will happen 6 or 7 or 10 years later for tuberculosis, very long, and maybe for COVID-19 it will happen in Czech like this, but nobody, I don't believe it. But anyway, it will take between 1 and 10 years from here to there. But to reach here as early as possible, you have to know what you want to sell. Yeah? So you have to define in a very early stage what you want to have in your bottle or in your glass or in your ampoule once you're in the market. And you have to define it, what do you want. We did this, for instance, for the tuberculosis vaccine. We said, because the tuberculosis vaccine goes to least developed countries, you have to continue to put it in the same vial, having it look like the same as it looks already. Because as I'm also coming from marketing and pharma, people who cannot read, who don't know, they are very much confused when you change the color or when you change the shape or when you change anything, except the writing, of course, the ampoule. So we said we need the same flask as is sold today in South Africa. Yeah? It's not least developed, but sub-Saharan Africa, sorry. Yeah? So that was number 1. Ampoule, lyophilized. It needs to be lyophilized because it has to sustain high temperatures, low temperatures, temperature changes, humidity, everything needs to be, looks the same, has to be the same. This already puts some burden on the development because when we know that we have to lyophilize the product, we have to find a good lyophilization, yeah, for this strain. And we knew that we didn't want to use the same surface fermentation as it has been doing, is still being done today for this BCG vaccine. So we knew that we have to do a submerged fermentation. So these things came on top. So we had a lot of criteria to define in the beginning of the program. But this helped us a lot to be very efficient towards the end. Of course, in the meantime, when you start during the process, you make adjustments, but it helps a lot. It requires a lot of time and a very, very good network. That's why I said this board needs to be very strong. You need to know people from all these stages. You need to know pharma guys, you need to know regulatory people, you need to know for tuberculosis, WHO people, you need all these experts. And then, well, one of these experts in the Paul-Ehrlich Institute, that's, Ulrich was there, and Klaus Zichotek at the time, the deputy chief, Vizechef of Paul-Ehrlich, he was very much supporting VPM's developments and advising us. So we went there. You need to know a lot about GMP. We had a very good, from Beringwerk originally, advisor on GMP scale-up processes. You need to know how to fast-track development in the clinics, valid formulations. You need to make a good formulation. And okay, from all these sections you need experts. You need to group them together, and that takes months until you define this initial picture. Okay, now other learnings. Well, this was a learning, but this was also our starting principle. We said we cannot work differently. We have to work with the objective in mind. First we said we have to work with the end in mind, but then we said we shouldn't want the end. We want the objective. Can't end it. Now, what are our other learnings? This is also one of my principles. We always have to focus on the must-haves and try to distinguish between must-have and nice-to-haves. And what is really necessary to reach this objective and what is not so necessary. And then focus on the necessary stuff. So the plus of this learning and of this principle was successful and cost-effective production runs and clinical trials. We really were very fast. We made proof of concept after production and then clinic phase 1 for less than €4 million in less than 2 years. Yeah? So this was really fast and effective. Yeah? Nobody believed us that it could be so cheap. The guys in US, funded by BMG, by Bill and Melinda Gates, they spent 100 millions and did not reach this stage. Yeah? So this, we were good in it. But maybe too much focus on the operations. What I missed, and this is in hindsight, looking back, that I did not do enough public relations, like publications. I should have published much more. And we should have been more on conferences. We should have got more public grants to get more known in the community, yeah? And more networking. Of course we were doing a lot, but we were only 5 people. So I was really focusing on the operation to get the results. But to communicate the results, maybe I should have hired another person and for the communication. And another topic for a company, we focus too much on diseases looked after the NGOs. What do I mean? Of course, malaria and tuberculosis are very, very big diseases and very, very harmful to many, many people. But if I want to make money with a company, this is a dangerous ground. Well, this developed over the years from 2000 as a dangerous ground because NGOs have become so strong. Bill and Melinda Gates Foundation has become so influential and strong that the big pharma companies don't go into these areas anymore because they know that they will be forced to sell for zero money the product in the end. The only company who can compete because they are producing the cheap vaccines is Serum Institute of India, the biggest vaccine producer in the world, producing hundreds of millions of vaccines for 1 rupee per dose, or for 10 rupees per dose, and not $10 per dose. And this is what the pharma industry like GSK or like J&J want. So, thinking from the company point of view, having to make money, it was not the right thing to work on tuberculosis and malaria. But we had to do, because the tuberculosis was one of the most brilliant patents which we find. And Stefan Kaufmann really did a great job. And now I'm so happy to see that this, what is it, VPM 1002, is in clinical trial here in MRI, for overall immune stimulation. Okay, another learning, good and validated IP is crucial for commercial success. I said this before. I have to tell you that all the 5 projects, even the one I was just applauding, had flaws in the patent. Because the validation of the results which are patented were still with the view of the scientist and not with the view of the industry guy. We have to repeat validation runs, not just show one experiment. We have to show 10 times the same result, to have a validated result. Not just take the one which was most beautiful, write a patent, write a paper. And some, but not Kaufmann, but another patent, that even was wrong. It just didn't work. The technische Lehre and the technical teaching did not work. So there we should have, I cannot say that. It's important to look for, and for you, if you're doing new patents, validate, make valid descriptions, product description. And the second, we talked already, I mentioned it already, I think government projects, grant projects should involve industry experts as well as professors. Can be professors anyway, as well as academic scientists. Yeah? That's just to help people go the right direction. Now, I don't know if I still have time. I'm using my time, but you have taken a lot of this time before. And we had the Verleihung before. Yeah, okay. So I still have some time. This is the second part, Bluecon. Wrapping up VPM, I think it is a success story. Thank you for mentioning this. It's still there. It can be used, but I would be more than happy to see another company of this type, to collect money from the market, from the financial markets, and from the grant market. It's not a market, but for you it's a market as well. Collecting grants, and then to fund other projects, which we have discussed a lot on your train. Yeah? I asked you maybe 1 or 2 years ago, who is on the train? Yeah? And then the lack, which project is on this train to be developed from bench to market? And of course the big problem is the money. Yeah? Who is funding this? Yeah? You have a small money for finding an antibody, but now you need millions for clinical proof. Yeah? And where is this money coming from? Yeah? And this money could come from a structure like VPM. Okay. Now, Bluecon. How this Bluecon came into existence was funny. In 2011 to 13, I was, as an external consultant, leading the development of this technology at a company called Darivo in Cologne. And I will tell you later what it is, just to show you the history and the development. And in 2013, the money for this project was stopped, the funding, and I had a chance to look for investors for this project. And I was looking in Europe, US, and China for about 3 years, until I found one in China. And when I had found this investor, in the meantime, Darivo was having big problems, and they just had stopped their lab and released all their people, fired all their people. So in middle of 2017, with a colleague, we founded this company in Cologne, And we hired some of the people of Darivo who were instrumental in the Bluecon technology. And because we knew that we will get this Chinese investment, which happened then, which was signed in end of 2017, that Zhejiang Youcheng Group from Hangzhou was buying the technology from Darivo. So we went into a little bit of risk because this could have happened that it would not be signed, but anyway, it was such a challenging topic that we did this. And then we established the lab, September 2017 already, for the strain development. We made some partnerships in Hangzhou for PLA process. Our partner, Zhejiang Youcheng Group, they founded a company in Hangzhou, DP. The lab in Hangzhou is focusing on process development. I am the head of both labs, so I'm leading the development in Cologne and in Hangzhou. And 2019, this is a stupid thing, sorry. So we started pilot phase end of last year at EW Biotech, a former ThyssenKrupp company. And we also started genetic engineering with brain in Zwingenberg. And we will be in demonstration plant and production plant at the end of 2021 or 2022. Things have changed a little bit due to Corona. We are a bit delayed in our plan by about 6 to 9 months. But if we look at the objective of this plant, it is quite aggressive plan still. Now, why I'm showing this, I want to send a few messages with this. It takes even a long time from finding a strain until even in the bioeconomy. Yeah? It takes a very long time finding a strain, getting the money, and getting it to the industry, getting it to the market. The other message is 3 years of search. Of course, I wanted to find, ideally in Germany, an investor, or in Europe, or in the US, because I was a lot traveling to the Fuel Ethanol Week and all these second generation meetings in US. Well, finally had to go to China. I knew China. I am doing business with China since 1997 when I joined Solvay as the director of the pharma business of Asia. So I knew China well. I have many friends there, many people who can help me, who can support me, but it's a lot of travel. So I thought it's more convenient to have. And I couldn't think that it's not possible to find for this project no investment in Europe. This was in 2011, in 2014. Today, maybe we would have found someone. Because what is the objective of this? Oh, well, there is something went wrong here when I made this. But forgive me that it is difficult to read. The objective of Bluecon, the solution to the objective, the challenge and the result. Something I did wrong. The objective is to make a low-cost lactic acid, L-lactic acid, in order to be able to produce a low-cost polylactic acid. Polylactic acid is a bioplastic, is biodegradable, and it is made, as the name says, from lactic acid. Lactic acid is made from sugar today, and so it's bio-based and biodegradable. The objective for this low-cost PLA is to replace fuel-based plastics, which are not degradable and which are fuel-based, by this PLA. Yeah. Why this didn't happen in the last 10 years? PLA is on the market, PLA is produced in the States by NatureWorks, in Europe by Corbion, former Purak, a few, maybe 600,000–700,000 tons, maybe less, 500,000 tons in total. 500,000 tons. The packaging plastic market in the world is 130 million tons. So huge, and very small is made PLA. Why is PLA not replacing more of this packaging plastic in the past? Because it was too expensive. Costs were about, sales price was about $3,000 per ton, while polyethylene goes over the counter for 1,000. And polystyrene, the most expensive, costs 2,200, 2,300. So we thought, let us reduce the cost from making PLA, then it will conquer the market. So by volume, we will conquer the market. How can we reduce the cost? We have to, and this is here, we have to find low feedstock cost and non-food, because when we want to do 100 million tons of packaging plastics, we shouldn't take this volume of stuff from the food market. So we should look at non-food products, which means we had to go to agricultural and forest residues. Low cost also means that we need a simple bioprocess, and the simple process is one where we throw the substrate in, the bug is there, and the bug digests the substrate directly to the product. Which is happening when you put yeast on sugar, you make ethanol or other products. But it's normally not happening when you put cellulose into a reactor. There is not much, there's not many bugs which can, in a reasonable, industrially reasonable time, convert cellulose or hemicellulose to sugar and then to lactic acid. So we were screening at the time, and this was one of the other funny things. Actually, we wanted to do ethanol in the beginning, and then we were screening for an anaerobic process to make ethanol from cellulose, and we found a bacterium which is called a caldicellulose eruptor, so breaking up cellulose in the warm temperature, 70 degrees, anaerobic. And when ethanol went down in price, we said, this bug also makes lactic acid. So that's how we actually jumped on the lactic acid project in the beginning. So this bacteria, this caldicellulose eruptor, digests the cellulose. It secretes cellulases. It secretes hemicellulases, silanases, and arabinases. And so the biomass is converted to the monosugars, to the monomeric sugars. And again, this monomeric sugar is converted to lactic acid by the same strand, by the same bug. And that's called a consolidated bioprocess. That's why we are called blue con. The con comes from the consolidated process, and the blue, of course, comes from the blue sky, which we want to create, not burning straw anymore on the fields in China. This is what we call blue con technology. And I thought in 2014, 15, I thought, well, I should get money for this in Germany. There are so many rich people who would want to fund this. Nobody wanted to fund this. Now, I'm jumping a little bit back. You will be surprised that even in, when was it, 1986, when I started in the industry, there was at that time BMFT, programs for making chemistry from biomass. But it took, from 86 to now, still not much is made from biomass. Now UPM in Leuna is investing into a big biomass thing, and this is the bioeconomy. This is the excursion into bioeconomy. 10 years after this nachwachsende Rohstoffprogramm, Christian Patermann as the program director for biotechnology, agriculture and food in Brussels, he established the program knowledge-based bioeconomy. So he coined this word bioeconomy in the end, or he and his team. But he's still one of the, I just met him recently in Bonn, he's 78 now. is still going very strong and still pushing us to move ahead with our bioeconomy programs. And then we had this National Bioökonomierat. Ah, this is in German again, sorry. Sometimes I cannot distinguish. We have the first BMBF nationale strategy, we have the from BML, Ministerium für Ernährung und Landwirtschaft. We had in 2017 a Altmaier from Wirtschaftsministerium to ask for a biotechnology agenda, and 2018 then the Industrial Bioeconomy Dialogue, which I'm part of, by the way, one of the working groups. And in 2020 now, you all know, we have the Wissenschaftsjahr der Bioökonomie, which shows the strong with the words in Germany. We have the Green Deal in Europe, as you all know, and we have, of course, the big sustainable goals, sustainability goals by the WHO. And so bioeconomy is a very huge topic currently and in the future. And without COVID, I think we would still have a lot of Friday demonstrations, and we would focus more on bioeconomy and climate than now. Coming back to Gruppe, again, I want to share with you some learnings. I was talking about funding already, yeah, and one of the issues that is, or was, which we had 5 years ago, was that the chemical industry doesn't like ideas to buy. Yeah? They don't want to spend money in buying ideas, not even patents. Yeah? It's not like the pharma industry, which looks at a beautiful candidate with some animal studies and invests a lot of money because they see the big value potential in that drug candidate. The chemical industry waits until they say, "Show me your sales. How much have you sold last year?" And that's a big problem for all the bioeconomy companies. Not only mine, but that was one of Darivo's problems. Developing enzymes, developing this technology, developing beautiful enzyme technology, but no sales. So, no sales, no buy. It's quite tough. At least prove in the demonstration plan. The demonstration plan is big. It's big cost. Costs millions. The company I was talking about, Corby Bioproducts, we have a plan, we need 3 million for a demonstration run. Then we will be bought. Yeah? But before, it's very difficult to get the first 3 million in the chemical or bioeconomy sector is difficult. Venture capital also starts to understand there are very few venture capital companies funding bioeconomy. Most are funding medtech and pharma, because there's more fantasy, more multiples also. Because the multiples upon exit in the bioeconomy sector are lower and come later. People don't like this. If I want to invest money and make money from the investors' money, higher multiple and earlier exit is, of course, more interesting. So we are hoping, and that is in this bioeconomy working dialogue group, we are hoping that government will step in and fund the bridge over this valley of death for this type of companies. But coming to the status where we are, I told you we have survived, yeah? We have overcome this valley of death because we got a lot of funding from our Chinese investor, who is now a shareholder, of course, but we still have shares there. And the 2 labs are fully operational, about 25 people now reporting to me in both countries and both cities. In the meantime, we have 6 patent applications. We have improved the strains, the productivity significantly from the stage of where we come from. We had our first cubic meter scale run. We will go into 10 cubic meter in the first quarter of 2021, sorry. And we are now gaining traction, finding industry partners. This is just an example. Normally, lactic acid is a liquid and it does not crystallize, only when it is very, very pure. And that's what we need for polymer grade. And here you see crystals developing in this distillation. And this is PLA, which we made from that, just as a sample. Yeah, learnings. It's quite challenging to manage a project cross-border and cross-national. Between Germany and China, we have different cultures. Chinese culture is a little bit more hierarchical than the German culture. When you tell in China to do something, people will do without much argument. In Germany, they will argue first and then do or not. So both has advantages and disadvantages. And bringing these together is the most challenging and most also rewarding job. Because it's like on a football team, you need to have the right people at the right position. And you need to have them collaborate. And that's a big fun. And in 18 and 19, I was traveling a lot between China and Germany. Spent probably a quarter of a year I spent in China. But since February, we had to switch, of course, like you, to MS Teams and WeChat, but which helped a lot my presence in Cologne. So the team, which normally saw me every month, is now seeing me every week. Sometimes they don't like it, but mostly they like it. Sorry. Yeah. And what we also saw, and that's why is helping us, this is luck, yeah? There's a complete change of mind in the markets. Because PLA now, PLA was a kind of neglected specialty, but now it's a hype. Everybody's asking me, when can we get product? Yeah, I could sell, but I cannot because I have no product. Okay, learnings 3. Of course we got funding, but this has to be spent in a prudent way, prudent manner, and it has to be spent. Chinese are even more pushy than every Western investor. They want to have everything immediately, yeah? Which is good. I love this. I love this speed of investment, of speed of thinking, and speed of going forward. Yeah, it's not like ignoring regulations. Just it's working faster. Yeah, they have a lot of regulations, like here. The regulations to get the lab installed in Hangzhou was the same as we have it here. It's just working faster. Yeah. And why I'm saying this, what do I do first in this project? We had the strains with low productivity, we had the challenge still to do process development, we have this challenge to treat the residue, the straw, the wood or whatever, yeah, to make it accessible to the enzymes of our strain. And we decided to go this way because without a productive strain, we don't need the other two. If we have a low productivity strain, we don't need process development. So we focused the first year of this development fully on microbiology and also on the genetic engineering. We established our own tools, genetic engineering tools to improve the strain. And now, of course, as I said, we are looking in the pilot scale, and then in parallel we are looking at the pre-treatment optimization. Which also means another topic which may interest you when you are founding companies or have founded companies. There is a need for a gradual education of the organization from a research company via development company towards industry. Because we need the creative researcher in the beginning to make it happen that the strain is getting better. But the more we are getting closer to the pilot plant and to the industry, to the factory, we need systematic work. We need industry-like process development people. And also the mindset. As I said, my guys in Cologne, they were happy to have the lactic acid in the soup, in the reactor, in the fermentation broth, sorry, when I say soup. Fermentation broth, and detected by HPLC. I said, we need to get it out. We need to do the downstream, the purification. Yeah? And we need to do it controlled. Not only show that it is working, but what is the cost? What is the yield? We want to be cheaper. That is our objective. Yeah? So that means a lot of mindset change. Yeah. So, now we are on our way to our next financing round, to substantial industry partnerships and to production factories. And I've shown you this in the beginning, and this is my main message: from idea to product is the name of your networking platform. As I said before, the researcher thinks of the molecule. This is another product I'm working on, the long-chain diacids. The product is the substance. And for me, in industry, the product is the substance in big bags. Yeah. And thank you very much.